Hello everyone and welcome to today's video on simulation in transportation engineering. So in today's video we're going to be looking into the concept of simulation. We are also going to be looking into the various types of simulations we have and also pointing out the key differences between the major two types of simulations and why exactly do we make use of simulation in transportation. That is also another point we're going to be looking into. And finally, we are going to be looking into the popular softwares we have in simulation in transportation engineering. So these are some of the concepts and these are some of the points we're going to be looking into in today's video. So without wasting much time, let's go into this. So when we're talking about simulation, most especially in transportation engineering, it's all about utilizing simulations to model and analyze transportation systems, allowing engineers to be able to evaluate the possible impact of different designs or control strategies and policies before implementing in the real world. So that is a place where we have a realistic view of what a system will look like or what a transportation or a design will look like and how effective it will look like before the implementation in the real world is done through using simulation. So that is the idea of running a simulation because most of that is the terminology we use. We say we run a simulation. So in mostly in transportation engineering, we try to look at understanding, okay, if we know we want to set up this traffic light or this traffic network in this particular area, how will it react? So we need to have a system or this model or running it in a simulation network or software to have a realistic understanding of how it will interact with the environment. And this is done using simulation. So after when this is done, then we now see how we can implement it in the real world. And one of the advantage of using simulation, most especially because we're focusing on transportation engineering or in transportation system, is that it helps to optimize traffic flow. That is a system where there is efficient and effective transportation movement of people, goods, or whatever it is, and also enhance safety. That is reduction of to help to reduce congestion by providing a virtual environment to test various scenarios. So in this simulation, you can test different forms of scenarios. How do they interact? How do they work in that environment during the course of testing or running the simulation? So it gives us that picture. So the the understanding and the interaction within that simulation helps us to see how well we can replicate that in the real world. So simulation is just a place or a ground where it's just a testing ground. I think that is the best word I can use. It's just a testing ground for any implementation that is going to be done in the real world. So before any transportation implementation or traffic implementation or railroad design implementation is done in the real world, it is first developed or tested or modeled in different scenarios in a simulation in a simulation environment or in a simulation system. So that is what simulation is. And from what we can see here in the on the slide, it says it's used for roads, intersections, public transit, etc. Using computational tools to analyze the performance and optimize design. So the use of there are some computational tools that are used in order to make this effective. So so we have the types of simulation. We have what we call the microscopic simulation. We have what we call the macroscopic, and we have the hybrid or the mesoscopic simulation. They work in different ways. First, when we're looking at individuality of of persons, of vehicles, when we are paying attention to individual elements within the simulation, that is what we talk that is when we look into the microscopic. From the word micro, it comes to talks about the minutest detail, looking into the details, the elements, the performance, the characteristics of each element within that simulation. Then we look into the microscopic. But microscopic talks about the general view, a traffic network. Having that bigger view without taking into cognizance the each element or the minutest element within the system, talking about the individuals, talking about the items, or probably talking about the vehicle elements in that simulation. But hybrid or mesoscopic combines microscopic and macroscopic. So we're going to be looking into this also. So looking into the first one, which is the microscopic simulation, like I explained, it simulates individual vehicles. It focuses on individual vehicles. It focuses on the interaction between individual vehicles. Taking a look at the acceleration, taking a look at the characteristics and the lane changes, the braking. Taking a look at what I'm looking for the right adjective to use here. The way it works within the simulation flow. So it pays more attention into it, taking a look at the speed per hour, taking all those things into consideration. And that is why we say microscopic focuses on individual vehicles or elements within the simulation network. And some of the cases we've seen in this is when we look into the traffic signal optimization. When we're looking at optimizing the signals, you need to pay attention to each of the vehicles and not a general view of those. Intersection analysis, how do vehicles interact in an intersection. So when we want to look at the analysis of an intersection, it is very important to pay attention to individual vehicles. And also autonomous vehicle testing. When we want to test vehicles, self-driving vehicles, we do not look at it in the general view or on an aggregate view. We look at it based on individual vehicle testing to be able to see how they react and how it works before the implementation. Also, pedestrian vehicle interaction, having a good understanding of how vehicles and pedestrians interact, how they work together in a road system or at the point of a traffic intersection. So this can be done using microscopic simulation. Though there are some softwares in which you can use for some of those things. We're going to be looking into that in the later part of this video. Then for the macroscopic, we said macroscopic models traffic flow as aggregate quantities, that is density, the speed, the flow. It looks at the aggregate, not specific or individual vehicles. So when you're focusing on a bigger picture of the traffic flow, then we're looking into the traffic and macroscopic simulation. And what are the cases is used when it comes to regional traffic planning? You can see it has to do with planning compared to when we're looking into microscopic, which talking about intersection analysis, talking about the pedestrian vehicle, understanding of pedestrian vehicle relationship. But when it's macro, it's talking about use them for traffic planning, for capacity analysis of the highway, looking at calculation of the emission estimation at city scale. So when you're looking at the bigger picture of of a traffic system, then or a transportation system, then we make use of the macro simulation. Then the last one is the hybrid or mesoscopic simulation. That is, it's a middle ground. When you have a middle ground between the micro and the macro, so group vehicles into platoons but still consider some individual behavior. Fine, we are grouping vehicles into a set of a group or a platoon, but still we are still not looking, we are also still looking at the behaviors of each of those vehicles. We are still trying to understand the behavior of each. So it's not just focusing on the individual vehicles or individual vehicle behavior, but even when we group them, we have them in a group which is tending towards the macroscopic, but still we still take a look at the individual characteristics and how these individual vehicles behave in the simulation. So we know, and some of the uses is for large scale network with moderate details. That is, the details are not too comprehensive, just minute details, and also evacuation planning. That is when we tend to make use of hybrid, or we also call mesoscopic simulation. Now, we have these are some of the popular software simulation softwares we have. For some of you that have been following with us videos or on this platform, you will notice that we've been able to look into SUMO before now, and not just looking at the concept of SUMO, we are also able to look at the theoretical, and we're able to run a simulation using the SIMO software. I think we've done that. For some of you who haven't been able to see that, you can check for some of the other videos on our YouTube platform. You can see some of the videos we made using SUMO software. And we say for the SUMO, it can be microscopic and it can also be macroscopic. So it combines both types, or two of the three types of simulation. That is, it can be microscopic and it can also be macroscopic. And the strength is that it's an open source. Not every of these softwares are open source, but this is an open source and highly customizable, so you can detail it to your own taste. You can mirror it in the way whereby you want it to, how you want it to look like. And when we say it's an open source, that is, it is publicly available. That's a public available source code in which can be used for it. So it's made public. It's made available to the general public. And the next one is VISSIM. I think I will still be making videos under VISSIM. We're going to be looking at some of the core concept of VISSIM, and also maybe run one or two simulations, simple simulations using VISSIM. But VISSIM is microscopic in nature, is microscopic, and some of the strength is industry standards and detailed driver behavior. That is, there is much more concentration on the driver behavior when using VSIM. And I think in some parts or in some industries, they prefer the use of VSIM than the use of SUMO or any other software. And the next one we have is Anylogic. We're also going to be doing the same thing. I think we'll be trying something out under Anylogic, maybe setting up a subway network and also maybe an intersection. So I think we are going to be making more videos on that. Just run one or two simple simulations on that, and we can see here that it is micro, macro, and agent based. And the strength is that it can be flexible. It supports hybrid models. And another one is IMSON. It can be microscopic and mesoscopic, and this can be used for dynamic traffic management. And we have Transmodeler, which is micro, macro, and hybrid. That is GIS integrated and large scale modeling. So these are just some of the softwares, but I think we've been able to take enough simulation examples under SUMO, but we are going to be looking more into the VISSIM and the Anylogic. So I'll be making more videos on that in the nearest future. So you can stay tuned for that. So what are the key differences between microscopic and macroscopic? I think we already explained that, and that is looking at the individuality. So first of the features is the level of details. We know in microscopic it is individual vehicle driver base, compared to macroscopic, which looks into the aggregate flow, looks into the general flow. It does not pay attention to individuals, but it looks at the general view of it. And when you are looking at the computational cost for microscopic simulation is higher because of the concentration on individual vehicles or drivers in that simulation, compared to macroscopic, which has this low computational cost. The third point is the output metrics of microscopic simulation. It pays attention into the speed, the acceleration, the delay. But when we're looking into macroscopic simulation, it focuses on the flow rates, the density, and the travel times. And some of the tools in which we already explained before now. Under microscopic, we know we can make use of SUMO, which can also be used in macroscopic. We have VISSIM, which is just strictly microscopic. We have Anylogic, which is agent based. But under macroscopic, we have Anylogic, which is system dynamics. So these are some of the key differences we have between microscopic and macroscopic simulation. So here we are going to be looking at why do we make use of simulation in transportation. These are just some of the reasons why we use simulation in transportation. The first one is cost effective testing. Cost effective testing. I think this is self explanatory on its own if you have been following under this lecture on the simulation, because when we look at the cost effective testing, I think that is one of the major reasons why we use simulation in transportation. You cannot say you want to set up a bridge or you want to set up a road network and doing it based on trial. Okay, let's just see how it happens. Let's see how it comes out. That's what if it does not come out the way we want it to. So, but simulation gives us a ground to have a realistic view of how the transportation network or the intersection or the traffic light use will be effective. So, giving us a good um, sample or giving us a good look of what it will look like when it is being implemented. So, and that saves us a lot of cost when it comes to testing. So it helps to avoid expensive real life trials. When you want to keep trying, let's just run a small trial, let's run a small trial. Rather than doing that, simulation helps and gives us a good view without necessarily running some extra cost with testing or seeing how a transportation network or whatever thing we want to set up in the transportation field will turn out to be. The second point is risk-free experiment. Test extreme scenarios. So it helps us to be able to test extreme scenarios. We would not have a good understanding. There is no way we'll be able to look into this point without taking a look at maybe looking into accidents or disasters. This helps us to have a good understanding because we cannot okay, let's set up a disaster or let's set up an accident because we want to see or we want to see how we are going to react to it. So simulation helps to have that first hand experience of those extreme scenarios like accident, extreme scenarios like disasters, whether it is man-made or natural disasters. So that can be done using simulation to see how it plays out and how well we can deal with that occurrence. So that is another reason or another reason why we use simulation in transportation for risk-free experiment. And the third point here is performance prediction. That is forecast traffic impact of new development. It helps us to be able to make adequate forecast of the traffic impact when there is a new development. When you set up let's for example in a city, when you set up new industries that brings about employment of people. So that means that there will be a need for more people coming into that city or more people coming into that state or people tending to use transportation modes more because of the new industries or new setups in that particular area. So through simulation, it helps us to be able to forecast the traffic impact of any form of development that has been done in a city or a state. Then the next point is optimization. That is, it helps to be able to improve the traffic flow. It helps to be able to reduce delay and lower emission. So when we use that, it helps us to be able to achieve that and the implementation of that in the real world. And the last point here talks about the policy and planning. So evaluate public transit expansions in toll system. So that can also be done using the simulation. So help us to look at the possibilities and to evaluate the public transit expansion. Is there going to be a need to expand? Looking at the system we are able to design using the simulation, would there be a need for us to expand the public transit, or is there a need for us to evaluate it again, or the toll system, should we continue with the one we're using, or looking at the new development in the city, is there a need for us to evaluate the toll system? So all these things can be done using simulation before the real life implementation. Here we have some of the practical example scenarios. We have already explained this. For microscopic, the problem, why is this intersection causing delay? So then when we notice that an intersection is causing delay, then the tool, you can use VISSIM to model and driver's behavior, the signal phases and the queue length to understand the causes of that delay. And from that use of this tool or use of this software, you can be able to adjust whether looking into the signal phases or increasing or reducing the queue length and the signal timing to be able to accommodate or to be able to deal with the problem of delay at the point of intersection. So another one is the macro and under the macroscopic we have the problem like will a new highway reduce citywide congestion. So making use of SUMO with OD matrix, the OD we have there means origin and destination, so taking into consideration the origin and the destination matrices to estimate the traffic distribution. So how can we distribute that traffic from the origin to the destination? And this can be done using SUMO. Like we said, it can also be used in a microscopic macroscopic basis. And so, and the last point here is the hybrid, which is also called the mesoscopic simulation. And the problem could be, how will a subway line affect road traffic? We know we have a subway line, so what relationship or what interaction will they have with road traffic, and how can it affect? And we can make use of Anylogic to combine the macro traffic flow, and this is the importance of it, looking into the macro traffic flow plus the micro pedestrian movement. So combining these two will help us to have a better understanding of how a subway line can affect road traffic. We have it also in the cases of in the implementation of a tram line. When you have a tram line on the road where we have the the combination of the tram line and also the movement of vehicles, pedestrians on that road. So through the use of this hybrid simulation, it can help to combine this and to help to have it to be able to come up with a definite system on how to combine this effectively. So looking at the conclusion on this, we already said that microscopic is small and detailed interaction, whether it is talking about the driver's behavior or whether it's looking into the individual vehicles or the characteristics or the behavior of each of those vehicles. So it's microscopic. Then macroscopic has to do with efficiency on a large scale, looking at the aggregate traffic flow, the aggregate data, talking about how it can be used for urban planning or decision making. And the last point is the hybrid or the mesoscopic, talking about the balance between the micro and the macro, that is moderate details for bigger networks. So that helps us to round up everything. At least just is just an introduction into what simulation is in a traffic or in transportation engineering. Thank you. And I think, like I said, in the maybe in the future I'll be able to come up with more videos under VISSIM and also under Anylogic. So we'll be able to make a video introducing some of the elements we use, some of the computational tools we use in this to um, simulation software. I think we already done that for SUMO and we had some examples on it. Or we're able to do the same also for Anylogic and VISSIM in the nearest future, just to have an idea of what it is like. So I'll see you in the next video. Thank you.